This video presents the paper, Flocking-Segregative Swarming Behaviors using Gibbs Random Field. In this work we present a novel approach that allows a swarm of heterogeneous robots to produce simultaneously segregative and flocking behaviors using only local sensing. These behaviors have been widely studied in swarm robotics, and its combination allows the execution of several complex tasks. Our approach consists of modeling the swarm as a Gibbs random field and using appropriate potential functions to reach segregation, cohesion and consensus on the velocity of the swarm. Simulations and proof-of-concept experiments using real robots are presented to evaluate the performance of our methodology in comparison to some of the state-of-art works in segregative behavior. To evaluate the segregative behavior considering only local information, we compare the convergence rate of our approach against the one presented by Mitrano and Inacio. We consider the work proposed by Santos as a baseline since it assumes global knowledge about the positions of other robots, leading to a fast convergence rate. We also contrast our methodology with a deterministic gradient descent approach using potential differentials to show that such mechanism may be easily trapped at local minima. Analyzing the segregation using the number of formed clusters, we can see that all approaches executed relatively well for a small number of groups, but when the number of groups increases, our approach significantly outperforms the others, with a performance close to the baseline which uses global information. To evaluate the effectiveness of our approach in producing flocking behaviors, we added Gaussian noise to the sensor model so that the relative position and velocity estimates are not reliable. As expected, increasing noise in the sensor model significantly impacts the velocity consensus. For 10% of noise, we notice the velocity consensus degrading and, consequently, the flocking behavior does not converge. However, even with noise we are able to segregate the swarm to the minimal number of clusters most of the times for a sufficiently large number of iterations. To evaluate the feasibility of our approach in a real environment, we performed proof-of-concept experiments using 5 epoch robots. We can see that the robots can reach segregation and also keep the flocking behavior, but with some noise in the velocity consensus due to the uncertainties observed in real settings. There are several opportunities for future studies and/or applications. In particular, we intend to investigate the possibility of performing more complex tasks, such as transport and shape formation, using the GRF framework. Thanks for watching.